Today, we're diving deep into the hidden forces reshaping Canada from the inside out. The rapid glacial melt accelerating across the Arctic, the collapsing coastlines carved by warming oceans, the ancient carbon waking beneath thawing permafrost, and the scientific race to understand a landscape changing faster than anyone predicted. By the end of this video, you'll never look at Canada's land, climate, or future the same way again. Before we go any further, make sure you hit subscribe, because what we're uncovering today is only the beginning. The transformations happening across Canada are unfolding in real time, and you won't want to miss what comes next. Canada is warming at twice the global rate, and in the Arctic, that rate is 3 times faster. This isn't a distant forecast, it's a present-day reality. In 2025, a series of unprecedented heat waves swept across the country, shattering provincial temperature records. In Atlantic Canada, thermometers soared to a blistering 38 degrees Celsius, a temperature once unthinkable. National climate assessments confirm a stark truth. These extreme events are no longer anomalies, but a direct consequence of human-driven climate change. Heat waves are now more frequent, they last longer, and they are pushing our cities and natural systems to their absolute limits. Nowhere is this change more dramatic than along Canada's northern coasts. The Arctic shoreline is eroding at one of the fastest rates on Earth. On the Yukon and Beaufort Sea coasts, land that stood for centuries is now vanishing, with some areas losing tens of meters in a single year. The culprit? Disappearing sea ice. For most of the year, ice acted as a protective shield against the ocean's power. Now, with longer ice-free seasons, powerful waves and storms batter the exposed coastline, tearing away the land. Entire communities, sacred ancestral sites, and critical infrastructure are now facing the imminent threat of being swallowed by the sea. Beneath this crumbling coastline lies another, more insidious threat: thawing permafrost. For thousands of years, this frozen ground has locked away vast stores of ancient carbon. But as the Arctic warms, the permafrost is thawing, releasing that carbon back into the atmosphere as carbon dioxide and methane. Along the eroding coasts, millions of kilograms of this organic carbon are swept into the Arctic Ocean each year. This creates a dangerous feedback loop. Warming thaws the permafrost, the thaw releases greenhouse gases, and those gases accelerate even more warming. It's a geological domino effect with global consequences, turning what was once a stable carbon sink into a potent source of emissions. This rapid thaw is a key part of what scientists call geocarbon feedbacks. When ice-rich permafrost collapses, it doesn't just thaw from the top down. New lagoons form, and the submerged permafrost degrades much faster than it would on land. The thaw spreads deeper and wider, unleashing carbon that has been frozen since the last ice age. The landscape itself is becoming an active participant in accelerating climate change. And it's not just the ground that's changing, the ice itself is in retreat. Canada's Arctic glaciers, jewels of the North, are losing mass at an alarming rate. Some have receded by hundreds of meters, even kilometers, in just a few decades. This meltwater flows into the ocean, contributing directly to global sea level rise, and it fundamentally alters the flow of northern rivers, disrupting entire freshwater ecosystems. As the glaciers pull back, they expose new, unstable terrain to erosion and further thaw. While the North experiences these dramatic changes, another, much slower geological process continues. Much of Canada is still rising, a phenomenon known as isostatic rebound. The land is slowly springing back, millimeters at a time, after being pressed down by the immense weight of Ice Age glaciers. While this rebound doesn't cause continental drift, it's not insignificant. It subtly reshapes the landscape, influencing drainage patterns and interacting with the effects of permafrost thaw and coastal erosion in complex ways. A slow, ancient geological rhythm is now meeting the frantic pace of modern climate change. This new reality is putting immense pressure on the infrastructure we depend on. Our roads, railways, bridges, and pipelines were built for a stable, colder climate. Today, they are buckling under the strain. Intense heat waves warp asphalt and expand steel bridge components, while in the north, thawing permafrost causes the ground to heave and slump, destabilizing building foundations and creating sudden sinkholes. Engineers are scrambling to develop new standards and retrofit critical infrastructure, but it's a race against time, and the response is uneven across the country. The sheer scale of this crisis has pushed scientists to consider once unthinkable solutions. In the Arctic, small-scale experiments in geoengineering are beginning. These interventions, like making clouds more reflective or modifying the brightness of the surface, aim to slow sea ice loss by reflecting more sunlight back into space. But these technologies are fraught with ethical dilemmas and scientific uncertainty. Could they trigger unintended consequences for weather patterns, ecosystems, or even international relations? We are at a turning point, shifting from passively observing our climate to actively trying to influence it. Even the sky above us is changing. As we've cleaned our air of certain pollutants, we've inadvertently allowed more sunlight to reach the surface, adding to the warming. At the same time, the loss of reflective sea ice means the Arctic Ocean is absorbing more heat, a change so significant it's altering atmospheric circulation patterns. Cloud cover is shifting, affecting where and when rain and snow fall. The very air we breathe and the clouds that drift overhead are no longer innocent bystanders. They are integral parts of this new, dynamic climate system. Canada stands at a crossroads. The natural systems that have long defined its identity, its ice, its coastlines, its frozen ground, are transforming faster than our policies and infrastructure can adapt. This transition will not be uniform. Some regions may find opportunities in innovation and adaptation, while others will face immense struggles with resource scarcity, displacement, and profound landscape change. The future stability of this great northern land and its role in the global climate system hinges on the decisions we make today. The ground beneath our feet is no longer as solid as we once believed, forcing us to ask a difficult question: how do we build a future on shifting ground?